Hi everybody, this is just me going to be talking about forces. It's topic P8 from GCSE. I'm going to be talking about it to the combined level, so we'll probably be leaving out a few things that is triple only. And I'm just using this revision placemat that I got off of TS. Thank you to the creator. So I'm just going to work through it, talk about it, write it down. I apologize for my writing in advance, but here we go. So what is a scalar quantity, and give examples. So a scalar is a quantity with only magnitude. So it's something that only has a size. We only associate a number and a unit with it. Okay, some examples are mass, energy, distance, speed. And there are a lot of other examples as well. Volume, area, numbers of things. Those are all quantities that are just scalars. So a vector has magnitude and direction. And some examples include velocity, displacement, force, and acceleration. Okay, so yeah, that's it for the difference between a vector and a scalar. And just remember, velocity is the vector, speed is the scalar, displacement the vector, distance the scalar. All right, contact force. So what is a contact force? A contact force is a force that requires contact to occur. In other words, if two things aren't touching, these forces can't occur. And examples are friction, drag, air resistance, the reaction force is another example. There are loads and loads and loads of examples. In fact, we're only going to worry about 3 forces that are non-contact forces. So a non-contact force can act over a distance. In other words, two things don't need to be touching in order for there to be a force between them. And it doesn't ask for examples, but I'm going to give you some the 3 examples. You've got gravity. You've got electric forces, electrostatic forces, and magnetic forces. Anything that's not one of those 3 forces will be contact forces. Okay, so why is air resistance a contact force? It's because you need contact with the air in order for there to actually be a force. So without that contact, you are not going to be able to measure it. Okay. So what is mass and what is it measured in? So a mass is, well, how much stuff makes up something. It's literally how much stuff is there. And we measure it in kilograms. Okay? You can use grams and that, but the standard SI unit is kilograms. How can weight be measured? Well, we measure it with a Newton meter or a top balance. Okay, so we can use balances because we're actually always measuring weight and then converting to mass when we're measuring things. And it's measured in newtons. Okay, the resultant of these two forces, okay, because they are in this sort of triangle here, I'm actually going to move my 6 over here. Okay, so I've now got a 6 Newton here, and the resultant force connects through here, and you should use a ruler for this. That's my resultant force. Okay, and how could you calculate the resultant force? Well, a squared plus b squared equals c squared. So F squared is equal to 10 squared plus 6 squared. That is 100 plus 36. So F squared is 136. F is square root of 136, which is about it's 11.5 or so without using a calculator. So it's around 11 and a half, somewhere between 11 and 12. As long as you get that, then your calculator probably spit out the right number. All right, what is meant by a resultant force? Okay, a resultant force is the overall force when all force vectors are added together. Okay, you could probably get away with just saying the overall force, but it's basically you are actually adding all of the vectors together to find out what they are. What can you say about the motion of an object if forces are balanced? The motion is unchanged. Okay, if we have balanced forces, nothing, the direction, the speed, they stay the same. Even if that speed is 0, it means that it's staying the same. What can you say about the force a football will exert on the person's foot when they kick the ball? In this case, it's equal and opposite. Okay, if you kick a ball with 35 newtons, the ball hits your foot with 35 newtons. There's no way around it. Okay. Free body diagram of a box being pushed along the floor. Okay, well, the box is on the floor, so I've got my box. Box is going to have its weight. The floor is going to have a reaction force or a normal force. We are pushing with a forward force. And there will be a friction force. Okay? These here should be equal to one another, and these two should probably be equal to one another. It doesn't specifically say constant speed, but it just kind of naturally happens. Don't worry about this one. Don't worry about this one. And we're not going to worry about this one for this upcoming test, so I'll say leave those 3 alone. Okay. What is meant by an object's center of mass? Okay. Well, the center of mass is the point at which all mass for the object is concentrated. Okay, it's where all the force, it's where all the mass is concentrated, it's where the weight acts through it, and actually you should be able to describe or explain how you find the center of mass of a an irregular object. Okay. Explain the difference between speed and velocity. Speed is scalar. Velocity is a vector. That's it, really. If you have a direction, you have velocity. If you don't have a direction, you have speed. All right, that's it for this particular video. I hope it's been helpful.